Welcome to AP Biology. We are talking about cellular respiration, but I'm really not ready to dive into cellular respiration with you yet. We have one more video of background information that you need to know. And so I want to introduce you to some delivery molecules today. So in our last video, we talked about redox reactions, oxidation and reduction, where one molecule gives up its electrons to another molecule. The molecule getting the electrons becomes more negative, it's reduced. The one giving up electrons is called oxidized. So that happens a lot in cellular respiration where electrons are moved from one place to another. And so there are these transfer molecules, these delivery molecules, which pick electrons up from one molecule and bring them over to another molecule. While they're transferring electrons, they usually transfer hydrogen as well. And those are important during cellular respiration. So there are two delivery molecules that I need to talk to you about. Are you ready? This part's a little silly, but I feel like it helps. So anyway, here's our first delivery molecule. He's called NAD+. The full name is nicotinamide adenine dinucleotide. You don't really need to know that, but he's our delivery person. And so see here, instead of flowers, he doesn't really have flowers, sorry. He's actually traveling with electrons and a proton. So remember, a hydrogen atom is made out of a proton and an electron. So if you break those apart, you have an electron and a proton, right? And so this proton is really just a hydrogen ion, and then you have an electron. So we've got that, and then plus an extra electron. When this molecule has the extra electrons and the hydrogen, you call it NADH. So when I'm carrying these electrons and one proton, you can call me NADH. And I'll show you the molecular structure in just a minute. So NAD plus molecules pick up electrons and a hydrogen ion, and those are removed from glucose. So the glucose gets oxidized. So if you remember with reduction, you're getting more negatives, so you're getting more electrons. Oxidized means you're getting rid of electrons, you're giving them to somebody else. So glucose gets oxidized for energy. You release energy when you get oxidized. So glucose gets oxidized, and the NAD plus gets reduced to become NADH. So I'll show you that in a minute. There's one other molecule that we need to talk about, Flavin adenine dinucleotide, or also called FAD, and she isn't bringing pizza. It's really sad. She's actually bringing electrons and protons too. So here she is with a proton and an electron, and then also another proton and an electron. So really, the electron and the proton is really a hydrogen atom. So she's traveling with two more hydrogen atoms. And so from FAD, she becomes FADH2. So FAD molecules also pick up electrons and protons from glucose. So glucose is again getting oxidized, FAD is getting reduced. So let's look at what that actually looks like. They don't really look like that. They actually have molecular structures. His looks like this. So this should look familiar to you. There's a sugar right here, two O's, so it's a ribose, right? There are some phosphates, there are some bases right here, right? So that should look kind of like a nucleotide, a couple of them together. And I don't care if you have that, you don't need to memorize him. You just need to know that NAD is, or NAD plus is a delivery molecule. Same thing with FAD. You just need to know, you don't need to know her structure. This is what she really looks like. You don't need to memorize that, although it should look a little familiar, right? You've got the sugar, you've got the phosphate, you've got the base. So it should look a little bit familiar as to something that we studied, but what I really want you to know is that they're delivery molecules. So for example, with her, if I gave you this picture, I would want you to be able to spot this spot right here where there's an extra hydrogen, right? And then this spot right here, there's an extra hydrogen. So she's carrying an extra hydrogen, which is really made out of a proton and an electron. So that means she's carrying the electrons. So this one over here has the extra electrons. So this is the reduced one. And I would want you to be able to recognize that. Going back this way, you're getting rid of the extra hydrogens, which means you're getting rid of the electrons. So this one's oxidized. Right? So the reduced form has more electrons. And same thing with this one. This is just a little piece of his structure. But what you can see is, let's see right here. See how this carbon right here has 1, 2, 3 bonds? You know it has 4 bonds really, so there must be a hydrogen on here. But whereas this one just has these two bonds, there are two hydrogens. So there's an extra hydrogen right here. And then, so that makes up a proton and an electron, right? And then if you notice right here, this is a positive charge, whereas we don't have that positive charge here. There's an extra electron here. So that takes into account the two electrons, this one and the one that's here, and then the hydrogen ion, which is a proton, which is that one. So anyway, this one has the extra electrons, so it's reduced. And then this one doesn't, so it's oxidized. So I don't want you to memorize these structures, but I would, if I showed you this picture, I would want you to be able to pick out which one has the extra electrons and is therefore reduced. Okay, so if you, let's see, look at the, so here's the reaction. So if you look at right here, you've got an extra electron right here, right? And let's see, and an extra proton and electron right here. So this one has more electrons, right? And so if you have more electrons, then you're reduced, right? NADH is reduced over here, so this is NADH, and over here it's just NAD. This is the oxidized one. So this one can take electrons from somebody else, so we call it an electron acceptor. It's getting reduced, so that means it's an oxidizing agent. And then NADH stores those electrons and gives them to somebody later. We'll talk about that in like a whole bunch of videos from now. It's going to take us a while to get there. So as we go through these videos, as we go through these notes, you need to keep these delivery boys and girls, these delivery folks in the back of your mind and know that someday you're going to find out what they're for, but it actually takes a while for us to get there. So it's kind of like reading a story where you're introduced to all the characters and you're like, oh my God, I wonder what's going to happen. Will they fall in love? What happens at the end of our story? And you just have to wait and see. It's a rough unit. You're going to be, I know, sitting at the edge of your seat thinking, what's going to happen? What's going to happen? All right, so a couple of other little points before we finish here. There are some enzymes. So look at this, dehydrogenases, ACE, 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 ACE. That will tell you that it's an enzyme. Hydrogen is hydrogen, right? And D means to take off. So these remove hydrogen, which is a proton and an electron from a molecule. So these are enzymes that take off electrons. So here's NAD becoming NADH. You need the enzyme to take the hydrogen and the electron, the proton and the electron from here, which is a hydrogen, right? And stick it onto here. And so the dehydrogenase is just an enzyme that makes this redox reaction happen. So these delivery molecules carry electrons to be used later. Dot, 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 dot. Can you hardly wait? I know, we can hardly wait to see what happens. We'll get there.